Suppose the wholesale price of a certain brand of medium-sized eggs P in dollars per carton. So we're not selling eggs by the egg, we're selling them by the carton. That's ordinarily how we do it. And it's related to the weekly supply X in thousands of cartons by this equation 625 P squared minus X squared equals 100. So just stopping and writing after our equation these variables we have X, we have P, and then we're changing with respect to time. So X, it says, is in thousands of cartons. So if X is 5, that doesn't mean they're selling just 5 cartons of eggs. That means 5,000 cartons. P is their price in dollars per carton. Again, they're not selling eggs by the individual egg. They're selling them by the carton of eggs. And then it says weekly supply. So T must be in weeks. So from this, we're going to get an X equals. We're going to remember that's in 1,000 cartons. And then we're going to have that change with respect to time when we take the derivative. So we'll get a dx dt, which X is in thousands, or 1,000 cartons. And T in the denominator is in weeks. So this rate of change is going to be in thousands of cartons per week. And then we're going to get a P equals, which is going to be in dollars. It's the price per carton. And dp dt, the derivative of P, with respect to time, is going to be in dollars per carton from P, the numerator. And then the units with the denominator T, again, is weeks. So dp dt is dollars per carton per week. So now we have our setup with our units. This just really helps when we get all of these numbers and we're asked our question to figure out what we're given and what we're trying to find. So it's okay if we're missing a variable, we plug into the original if we're missing a variable. And we should always be missing a derivative because the final answer is we're given one derivative, here's one thing we know is changing, tell us what's changing with the other thing. So in this case, we're given supply, so we want to know how the supply and price are changing together. So the first part says if 25,000 cartons of eggs. So if I'm not sure where that goes because there's so many letters here, it's 25,000 cartons of eggs. What's in 1,000 cartons of eggs? The only thing that's just in 1,000 carton of eggs is X. So is X 25,000? No, X is 25 because that stands for 25,000 cartons, which I would probably mess up if I didn't take the time to do that setup. So we'll always do that in our work to the side before we start. So X is 25 because that stands for 25,000 cartons of eggs. That's our supply. It's available for a price of $1.07. So we just want the price, not how fast the price is changing. It just says the current price is $1.07. So P is the only one in just dollars. dp dt is dollars per week. And that's not how much it's changing by, that's the current price. So P is $1.07 at the beginning of a certain week, and the weekly supply is falling at a rate of 1,000 cartons per week. So our supply is going down for some reason. And we want to figure out how that is going to affect the wholesale pricing. What should we do to our price because our supply is falling right now? So supply is falling at a rate of 1,000 cartons per week. So I'm looking at what I have left. What's the only thing in thousands of cartons per week? It's this dx dt. So I need to write that it's falling by 1,000 cartons per week. So this is already in thousands, so I don't want to write 1,000 cartons. I just want to write 1. That stands for 1,000 cartons per week. But it's falling. So should this derivative be positive or should it be negative? It should be negative. It's dropping by 1,000 cartons per week. So what should we do to our price? Should we raise our price because we don't have enough supply to give the regular amount of people their eggs? Or is there some sort of controversy? Are our chickens sick or something with salmonella in our eggs or something like that, making it so that we should still have our price go down even when our supply is going down? Supply is really hard to predict. Demand is pretty straightforward because we're used to buying things. When prices go down and they're super low, we buy a lot. When they go up, we buy less. But demand is harder to predict. So I don't really know what we should do with our price when the supply is falling by 1,000 cartons per week. So let's find out. So after we do our whole setup, we're going to show our derivative with respect to time. So we're going to take the derivative of every piece. So I'm looking at this equation up here. Maybe I'll swap out color so it's clear. So our equation is 625p squared minus x squared equals 100. And we're taking the derivative with respect to time. So we're going to bring down the power 2. So 625 times 2 is 1250. And then we just have p to the first now, or just a p. And we took the derivative of p with respect to time. Next piece, we have the derivative of negative x squared with respect to time. So it's going to be minus 2x. Don't want to forget my dx dt though. We took the derivative of x with respect to time. Equals, and I definitely don't want to forget the derivative of that right side. Derivative of 100 is 0. So at least that goes away. So now I'm going to plug in everything I know and solve for what I don't. So I have 1250 times p. P is 1.07. By the way, if you have to solve for the price in WebAssign, you never want to round it until your final answer. So if it's a crazy decimal, leave it as what it is. If you took the square root of something, leave it as like the square root of 3.06 rather than making it a decimal that keeps going. So this one terminated, that's why it's rounded, but don't round your answer until the final answer if you have to find p. So 1250, we plugged in p is $1.07, and then we have dp dt, that's what we're solving for. So I'm going to leave it as dp dt. I'm going to find that after I plug everything in. Minus 2 times my current x is 25. Again, they're not just selling 25 cartons of eggs, they're selling 25,000. But dx dt is -1. Their supply is dropping by 1,000 cartons per week. So their supply was 25,000, but it's expected to drop by 1,000 cartons per week. So now I just need to grab my calculator and multiply these things out. And so I'm going to do 1250 times 1.07. And as long as that terminates, then I'll write it down. If it didn't, I would just leave it until the final answer, then I'll round at the very end. But this comes out to be 1337.5 dp dt. And then the next one, I have -2 times 25 is -50 times a -1 is going to make it a +50. Equals 0. So now I'm going to solve this like a linear equation. I'm going to move this 50 over because it doesn't have a dp dt. So I'm going to subtract 50 over to move it to the other side. And I'll have 1337.5 dp dt equals -50. And then I just divide to get dp dt by itself. So divide both sides by that 1337.5. So I will make this a decimal just so it makes a little bit more sense in terms of putting the units on it and figuring out what this all means. It's -0.0374 approximately. And what are the units on this? The units on dp dt we could look up here, or think about the units of p were dollars per carton, and then T was in weeks. So obviously we stop at the penny when we talk about dollars, so I'll write that down in my interpretation. So first we're going to say what was given to us, and then we're going to say what happened to what we found. So what was given to us, our derivative that we were given was this dx dt. So that stood for supply. So as the supply is what? It's falling or decreasing. As the supply is falling by 1,000 cartons per week. So start with the derivative you were given. Then say what's happening to the derivative you found. So as the supply is falling by 1,000 cartons per week, the price is doing what? If it's a -0.0374, is the price, should we raise it or should we lower it? Negative says we should decrease the price. The price is decreasing by, and we're going to round to the nearest penny just because we're talking about money. So you could say 3 cents, but really the 7 says I should probably round up. So I would say 4 cents per week. So supply is pretty tough to predict, but according to this model, if our supply is falling by 1,000 cartons, we should still be dropping our price by 4 cents per carton per week.